Hello and welcome. In this lecture, we are going to show how to represent and work on sets using programming language Python. So we already know that a set is a collection of objects called elements or members. For example, set of integers, rational numbers, and alphabets. Sets can be represented in roster form where all the elements of the set are listed separated by commas. Therefore, if we want to create set of elements 1, 2, 3, 4, we create it like this. If we want to create a set of name of colors, we create it like this: blue, red, green, black. And if you want to create set of square of natural numbers, we create it like this: 1, 4, 9, 16, 25. And if we print the results, we get it like this. Python can also be used to build set in set builder form. For example, if you want to create a set of square of first 10 natural numbers, we can create it like this: a is equal to x square for x in range 1 to 11. And if you want to create a set of letters in the word mathematics, we create it like this: b is equal to x for x in mathematics. And if we print it, we get this result. An empty set in Python can be created as follows: a is equal to set open bracket close bracket, and if we print the set a, it gives the result set is equal to set empty, which is empty. And if we want to print the length of the set a, we can print it like this: length of a, and it will show that the length of a is 0. We also know that the elements of a set are distinct. Therefore, if we try to create a set having duplicate elements in Python, it will not allow us to do so. For example, let us try to create a set here having duplicate elements 2 and 3. So we type the set C is equal to 1, 2, 2, 3, 3. There are two duplicate entries. If we print the sets, the Python remove the duplicate entries and give only distinct elements. A universal set is a set having elements relevant to a particular context. For example, if we have a set A having even numbers less than 20, and set B having odd numbers less than 20, and set C which is the square of first 5 natural numbers. So if we print these sets, we get this result. We can see here that the elements of all these sets are less than 20. So for this case, the universal set can be a set of natural numbers less than 30. Therefore, we can create the universal set like this: u is equal to x for x in range 1, 31. And if we print it, we get this result. In Python, we can also check whether a set is a subset of another set or not. For example, if we have a set A of natural numbers from 1 to 9, a set B of natural numbers from 8 to 11, and set C of natural numbers from 2 to 7. If we print these sets, we get this result. And if we want to check if B is a subset of A, we write is subset A. And if we want to see if C is a subset of A, we write C dot is subset A, and print the result. We see that B is not a subset of A and C is a subset of A. Python can also be used to graphically represent sets using Venn diagram. For graphical representation, we need two packages, matplotlib and matplotlib_Venn. Now suppose that we have a set A having elements 1, 3, 5, 7 and 9 and set B having elements 2, 4, 6, 8 and 10 and set C having elements 1, 4, 9 and 16. We plot the sets like this when 2 A, B, and we can label the sets as sets underscore labels. This is equal to A, B. So this is the Venn diagram of set A and set B. Similarly, we can plot set A and C like this when 2 A, C set labels A and C. And this is the plot of sets A and C. We can also plot all the three sets together like this when 3 in the brackets A, B, C, then set labels is equal to A, B, C. So this Venn diagram shows all the three sets A, B and C.